Assalamu alaikum dear student. I am Saqib Abbasi, your maths teacher, and my YouTube channel name is Math Sarkar. Today we have to discuss about very important topic of differential equation of further mathematics. Okay, dear student, what is the differential equation? Differential equation are those equation there is the one derivative term. For example, we have a dy over d of x. I have to rub that dy by d of x equal to x. Simple, that the equation which have involved are derivatives. Okay, now there is next one is we have discussed about the first order differential equation. What is the meaning of the first order differential? There is differential power is 1. Okay, if you look at there is one single derivative, we have to involve that. We say that it's a differential equations in first order. Okay, also we can write it dy by d of x equal to y square. Okay, we have to solve this one. Further we have to if we discuss about this equation dy by d of x equal to x, and dy will be here x dx divide and multiply by another side, take integration both side, this mean y and this mean x square by 2 plus c. Now, second one is we have to discuss about the integrating factor. Which the question which have the involve the integrating factor, I have to solve the question. And in this question, integrating factor involve. Okay, integrating factor. Okay, how we choose the integrating factor? Simple is that. Okay, dy by d of x plus y equal to x. First of all, we have to divide it by all equation is by x. Okay, dy by d of x plus y equal to x divided by whole equation by x. Okay, divided by x divided by x divided by x. Remember that the derivative part will be 1. Okay, the derivative part will be 1. These cancel, so dy by d of x plus y over x equal to 1. Okay dear friends, now the main thing is dy by d of x plus f of y into g. Okay, we have to write into this form. So remember that the the part of this one, the f of y, the part of y will be integrating factor. Okay, how we write it? Integrating factor by using integration 1 over x d of x. Okay dear students, e, there is log of x, and e and log are cancelled, so here we get the value of x. Okay, so this one multiply by here. Okay, it's mean we have to write it x multiply by here. So what will be the answer? Y over x into x. Okay, so here x and y by d of x plus y equal to x. So it's okay dear student, we have to write it into this form d over d of x into y equal to x, because if we take its derivative we get this previous equation 1. Okay, this is the differential equation, got the answer. Okay, next one is we have the question is about 14.3, very interesting and very important question. Okay, this is where you can find the general solution of cot of t dy by dt plus y equal to cosecant t minus sine of t. For that we have cos of t, we have to write it cos of t divided by sine of t dy by d of t plus y equal to cosecant t minus sine of t. Oh, and by using here integrating factor, we have to write it y over t plus y cosecant t minus sine of t. Here sine of t over cos of t over sine of t. Now what we have to multiply, actually we have to have working for, because this term will be 1, only dy by we have to require only dy by dt. So that purpose we have to multiply whole equation by sine over cos or tan of t. Both of this we have to multiply by t sine of t over cos of t. Here sine of t over cos of t, sine of t over cos of t. This required that sine and sine cancel, cos or cos cancel. So first we have dy by second one sine over t, it will be tan of t. Y cos t and cosecant t, it's been cosecant t and sine of t cancel, because look this one, cosecant t it will be sine of t and sine of t, these two terms are cancelled, only we have 1 over. So in this way, here sine and sine multiply with each other, so here we get sine square t over cos of t. Okay dear students, here dy by dt tan of t. Okay, now we have to simplify this one. How we simplify this one? We have to simplify this one, 1 over cos of t. Here we have a LCM, cos of t, 1 minus sine square of t, cos square of t, cos of t, which mean cos and cos cancel, we have remaining cos of t, so we have to put here cos of t. Dy by dt plus tan of t y, so remaining is here only cos of t, we have to simplify here. Okay, now we have to use the integrating factor. What is the integrating factor? Here is tan of t, this is our integrating factor. We have to use integrating factor is e power minus e power sine of t cos of t. Remember that cos derivative is minus sine, so that's why we have to multiply and divide by sine of t cos of t, multiply and divided by minus. So here this will be minus log of cos of t. Okay, now e power cos of t minus 1 log of e, it will be 1. So our answer is cos of t power minus 1 1 over cos of t, which is equal to secant of t. Hopefully dear student you have to understand this integrating factor multiply by this equation 1. So secant of t dy by dt plus tan of t y secant of t cos of t multiply by secant of t. Cos of t secant of t, it will be 1, because cos of t multiply by 1 over cos of t, these are these cancel, so it will be 1. Okay, secant t dy by dt plus secant t tan of t y, so it will be 1. So our differentiation, what is the differentiation here? Simple is that d over dt, first one, and this y, secant of t and y equal to 1. This is our solution. So in, if we take its integration, we get the answer is d over secant of t into y dt. Take integration, so secant of ty equal to x equal to this t, so it will be also t and plus c constant. Here y equal to t over secant of t plus c secant of t. Okay, now this shows that y equal to t over secant t cos of t c cos of t, we get this answer. Okay dear student, you have to understand this one. Now move forward. Hyperbolic t plus 2 e power 3t that has initial condition y equal to 0 and t equal to 0. Okay dear student, very simple. Plus y cot hyperbolic t 2 e power 3t. Okay, now integrating factor is simple, is that we have cot hyperbolic t. Okay, so e cot hyperbolic t dt. So here we get cot will be cos over sine, cos hyperbolic t sine hyperbolic t dt. If we more simplify that, sine derivative exists here, so here log of sine hyperbolic t. Okay, this log and e are cancelled with each other. Here we get so our integrating factor is sine hyperbolic t. Okay, now this sine hyperbolic t multiply by this equation number 1. So equation number 1 become equation 1 become sine hyperbolic t dy by dt plus y cot hyperbolic t sine hyperbolic t plus sorry uh, 2 equal to 2 e power 3t sine hyperbolic t. Okay dear friends, now further we have to use sine hyperbolic t. So our derivative d over dt sine hyperbolic t into y, and other side it will be, we have, if we simplify this one we have to, I have to simplify here. Remember that 2 e power 3t sine hyperbolic t, we know that e power t minus e power minus t divided by 2. Okay, now dear friend, this multiply by this one, these two are cancelled, e power 40 it multiply by this one, then this multiply by this one, minus e power 2t. Okay, 2t. So we have to write this one, this separation, there e power 40 minus e power 2t. Hopefully dear friend you have to understand this one. Now I have to use its integration, y sine hyperbolic t dt e power 40 minus e power 2t, it will be dt, integrate both sides. Here we get y sine hyperbolic t e power 40 divided by 4 e power 2t divided by 2 plus c. Now we have the conditions t equal to 0 and y equal to 0. So if we put this value in equation 2, equation 2 becomes, so this is 0 becomes c equal to 1 by 4. This is our required c value. Now we have to put c at this equation. We get y sine hyperbolic t equal to 1 by 2 e power 40, sorry it will be 4 minus 1 by 2 e power 2t plus c is 1 by 4. This is our required answer. More simplification, 1 by 4 sine hyperbolic t, it will be, because 4 will be common, e power 2t minus e power 2t plus 1. This is our required answer. Hopefully dear friend you